Good morning, one and all. Today our topic is identification of soil types, which is already in last class we understand what are the various soil types which are going to involve for identifying the different types of soil conditions. In this, which we are under various parameters. Based on the various parameters, we are going to identify the which type of soil it is. So based on these are the some of the characteristics which we are analyzing for assessing and identified soil type. So based on all these characteristics, we identified clay soil, sandy soil, silt soil, loamy soil and chalky soil. So now we are continuing this identification of soil based on their behavior and some tests. So based on characteristics which we are conducting, most probably for understanding the soil behavior, we are conducting all these tests. So characterizing problematic soil types involves a combination of in situ, on-site. Means in situ means those are the on-site and laboratory tests to assess for assessing the various properties and behavior of the soil. So in this particular class, we are understanding the what are the various sites are on-site or in situ tests, in situ test which we are conducting for understanding the behavior and various, what are the various characteristics which we are understanding from the soil. So the first one is visual inspection. So observing the soil color, texture, structure and any visible signs of distress or instability. So these are all without using any kind of chemicals, materials, equipment. For visual, when we are going to that particular site where we are do some project or construction work, before that when we inspect that particular site, based on the visual inspection, we are understanding which type of category it is. It is improved day by day and based on the experience of that particular person, it gives the better accuracy. So it is not get within one day and based on the strong background and strong knowledge about the soil conditions and soil behavior. So in the first one is already these are the basic physical, based on the physical appearance of that particular soil, we are concluded or we are understanding the type of soil. We are identifying based on the visual inspection. It plays a crucial role. So visually once we are understanding which type of category it is belongs, so in depth what are the various variations, even though similar kind of soil also based on the geographical and climatic conditions and environmental conditions also may influence the behavior of the soil. It may behave differently. It may be the same sort of soil. It may be same sort of soil, same kind of soil or same soil. We are giving two different environmental conditions. They are reacting in different ways. So like that. So those are all the parameters which are going to understand by visual inspection and we are getting the outline. We are understanding the outline what it is going to give and what are the problems we are going to face for the construction or which type of construction we are going to do based on that also. Type of construction also plays a major role. Which type of property is required, which type of property is required to enhance. So which property is going to damage or which type of property that particular soil has is giving some harmness to the particular structure, how we are going to reduce or how we are going to remove or any other another solutions, other ways we are going to look, alternatives, any other alternatives we may understand. So in that particular visual inspection gives the so much of understanding, but the minute things and the major strength point of view, the safety, all these parameters we are going to understand and at next level of test we are conducting. So in this visual inspection, as a geotechnical engineer or any other engineers, based on their experience, it gives the accuracy is going to increase. So now in this visual inspection, we observe the soil color, structure and another visible signs of distress or instability. You are understanding, and we are categorized and we are concluded, not totally, but partially we may understand which type of, it may be belongs to some side of soil, like that we are understand. Now move on to the next test, that is standard penetration test. This SPT, SPT standard penetration test, in this measure the resistance of soil to penetration by standardized sampler driven by a hammer blow. So provides information on soil strength and density. So based on this, we may not understand how density and the density, regarding the density of the soil, it not we may understand by visually. So we are going to conduct this standard penetration test. Then only we are knowing about the complete information regarding the density and that strength, regarding strength of that particular soil. These are all the parameters which we are going to understand in this standard penetration test. We will see later, we will understand how we are conducting, what is the procedure we are going to follow for this standard penetration test. We will see in further. So this is the one of the test we will conduct for understanding the density and strength of that particular soil, and what are the measurements are required for that soil is depends upon the which type of physical infrastructure we are going to do in that particular area. So these are the parameters which we understand in this. Next, moving to the cone penetration test, CPT, cone penetration test. In this, measure soil resistance continuously as a cone is pushed into the soil at a constant rate. In this, the provide information again soil strength, compaction and stratigraphy. These are the parameters which we are going to, these are the properties, the compaction, these properties which we understand by conducting the cone penetration test. So similarly, as like standard penetration test, in this also based on the what are the compaction values, strength values we will get, and which type of construction is going, that gives the measurements and that gives the idea about that particular soil. Now Van shear test. In this Van shear strength test, it measures shear strength of the soft soils on site by applying torque to a van embedded in the soil. It embedded in the soil. In this, we are understanding the shear strength of the particularly soft soils. In these soft soils, we are conducting this van shear test. The next one is pressure meter test. Pressure meters, in this pressure, based on this test, we are understanding the deformation properties by pressurizing any cylindrical probe inserted into the ground. So these are the on-site tests which we are conducting for identifying the soil type. So based on, we are understanding the shear strength and pressure, various deformation properties and compaction, strength, these are all density, These are all we are understanding for based on these on-site tests which we are conducting for understanding the various properties of the soil. Based on the properties, what are the requirements for the construction work or project. So we are going to follow the guidelines and we are going to enhance any requirement and any control measures we are going to consider based on all these tests. Similarly, we have some laboratory tests also. So in these laboratory tests, particle size analysis. This is the one which we are understanding whether the soil belongs to which type of size, whether fine aggregate, coarse aggregate, clay, silt, like this. And so based on that, first we have to analyze in this using the laboratory test. The first one is practical size analysis. In this, determines the distribution of practical size in soil using methods such as sieve analysis and hydrometer analysis. For this performing of practical size analysis, we have two different equipment is available. That is sieve analysis and hydrometer analysis. Based on that, we are understanding the particle sizes and how they are going to distribute. Next one is Atterberg limits. Based on this, we are understanding the liquid limit, plastic limit, and plasticity index of the particular soil. So it determines the plasticity of the fine-grained soils. This is for fine-grained soils by measuring their liquid limit, plastic limit, and plasticity index. So that gives the which type of material and how it is reacts when it moist. So the next one is consolidation test. So based on this consolidation test measures the rate and magnitude of soil consolidation under a load to assess settlement behavior. So based on these consolidation tests which we are under a load to assess settlement behavior. And the next one is the direct shear test. Direct shear test, here we are going to measure the strength of the soil sample under various loads. Those are normal loads and shear rates also. So in this which we are understanding and we are collecting those samples and we are measuring the shear strength under various different loads. The next one is the triaxial test. Coming to this triaxial test, determines the strength and deformation characteristics of soil specimen under various stress conditions including confining pressure and axial load. In this, determine the strength. Based on this triaxial test, it determines the strength and the deformation characteristics of soil specimens under various, based on the various stress conditions only we will get these kind of strength deformation. So including confining pressure and axial load. The next test is permeability test. It measures the rate of flow of water flow through soil samples to assess drainage characteristics and potential for seepage. The next one is the chemical analysis. Determines the soil composition including pH, organic matter content, mineral content and presence of contaminants. So based on the chemical analysis plays a very different role when compared to all these physical tests. Coming to the chemical analysis, which type of chemical, understanding the soil composition, which type of soil composition, it may be the same type of soil, but the composition, it may varies, and how much percentage of different kind of minerals, different kinds of organic matter which we are understanding based on this chemical analysis, including pH, which type of organic matter and what are the, how much percentage of mineral contains. It may contain different percentage of minerals may vary and it affects the various conditions also. So based on the same soil also having various mineral composition, various percentage of minerals which are involved, and the another property based some X property may affect because of the percentage of the various minerals also affects the conditions. So some of them they may be water absorption conditions and these heat, hydration, these are all the parameters we may understand clearly based on this chemical analysis. And also presence of the contaminants, how much contaminant of these various, how much percentage of various contaminants, based on the chemical analysis only we will understand. Next one is the XRD. These XRD and XRF, X-ray diffraction and X-ray fluorescence place, it gives the clear and we may understand the how the reactions are going to happen, how the mineral compositions are, how the molecules are attached, or whatever the inside, whatever the reactions, whatever the actions are going to happen, we may understand using this XRD analysis. It is identifies mineral composition. So how much percentage and how that will affect the another mineral, based on these percentage also it affects the combination of minerals are present in particular soil. So each combination, each type of mineral composition may affect the other, how they react and how it will comes out, and how will affect the environmental conditions or other various parameters it will affects. We may clearly understand this XRD analysis. In this, identify mineral composition, elemental composition of soil samples which can be provide insight into their properties and behavior. These tests help engineers and geologists and soil scientists to understand the characteristics, behavior and potential risks associated with the problematic soil, such as expansive clays, collapsible soils, organic soils and contaminated soils. So these are all gives the clear picture based on these XRD analysis. In this, the better understanding about the behavior of the soil we will get using this type of XRD analysis. And these XRD and XRF analysis give the clear picture of the mineral composition and their elemental composition, how they are reacting under various conditions, and how the behavior of the soil we will gives the better understanding this soil, and these it helps the engineers for understanding the potential risks which we are there in that particular problematic soil. So this is the one of the better way to getting the knowledge about that particular soil. This test gives the complete picture about the behavior of the soil inside there into their properties. So like this, these are the combination of all these on-site and laboratory tests provides a comprehensive understanding necessary. It gives the complete idea about the soil which is there on the site, and based on the laboratory test also we are understanding the which type of characters have that particular soil. Based on the required design gives the it gives the appropriate suitable measures and solutions for getting the betterment of the things. So in this, for designing it gives the better understanding and gives the better solutions for understanding all these tests. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.